Hello there, welcome to part 3. Now, there's a lot in this, and it's not hard once you understand it, but there's just a lot for me to cover. I'm on the third page here of your notes. I'm going to cross this off because you know what? We really did these questions on the last side. Here they kind of explain it, and there's a couple places where I find it confusing. So if you go back to the other video, I find it makes more sense there. If we think upstairs, downstairs, changing the exponent, change the sign. Okay, change location. So here we go as we move into evaluating exponential expressions when we have values for variables. You have to be really careful here with your parentheses and issues that we run in with that. So here we have this expression into the -4 times w to the 0. So to do this, they show us two methods here, so we'll work through them both quickly here. One is to first simplify. So that means taking into the -4 and go ahead and simplify the expression. So, well, that's currently upstairs, right? So I have to change its sign, okay, by using the definition of negative exponents, which is what we did in the previous video, really, into the fourth, all right, and then substitute the values right there. So you have n is -2. Okay, so the -2 is here, -2, and make sure you put that in parentheses when you substitute, because the negative has to get taken to the exponent as well. And then you have 5 to the 0 there. So 5 to the 0 is 1, all right, and then -2 to the 4th, that means negative times negative times negative times negative, it's positive, and 2 to the 4th is 16. It's 1 over 16, right? Now the other way you could do the same question is to just substitute it right away and do the math and work it out. I don't really care which way you use, just I want you to get it right. Probably that's the faster method. -2 to the -4th times 5 to the 0. Well, 5 to the 0 is just 1. All right, -2 to the +4. Okay, it's still 1 over 16 there for you. Okay, so a nice example of that. Let's take a look at the problem right here real quick. There's a population of insects that triples every week. The number of insects is modeled by this expression, 5,400 times 3 to the power of w, where w is the number of weeks after the population was measured. Evaluate for w equals -2, w equals 0, and w equals 1. Okay, what does each value of this expression represent in the situation? Well, here's what we know. All right, we know that 5,400 times 3 to the w, okay, that is the population of insects after w weeks from whenever they measured this. Here's what we need to know. We need to evaluate for w equals -2, w equals 0, w equals 1. The plan, we're going to substitute. Okay, we're going to substitute those into the expression and find the three solutions here. Really easy for us, I hope. Alright, so now let's solve the problem in this area right here. Alright, so since we're turning the page, I'll rewrite it for you. It's 5,400 times 3 to the w. And what we know is that w, I'll kind of break it up here, w equals -2. Let's just work that one out. If w is -2, we go 5,400 times 3 to the -2. All right. Now think about, what does that mean? If weeks is -2, what would that mean? That's 2 weeks before they actually measured these insects. And we'll get to that in a minute. But you have 5,400 now times 1 over 9. And you work that out, and that works out to be, equal sign there, equals 600. So that was the population 2 weeks before. If w equals 0, that would be week 0. I wonder when that is. Let's look at this. 5,400 times 3 to the 0. Well, we learned that 5,400 times 3 to the 0, anything to the 0 is 1, so that equals 5,400. All right, and then the last one where weeks is equal to 1, so 1 week after they measured the insects, so it would be 5,400 times 3 to the 1. And we multiply that out, and that comes out to be 16,200. All right, so what does each value represent? We need to interpret that now, and you might be asked to do that. If W is -2, the value was 600. Okay, so since it's negative, it says the value 600 represents the number of insects blank. We're supposed to fill in the blank here with the phrase 2 weeks before, okay, the population is measured. For W is equal to 0, we got 5,400. The value 5,400 represents the number of insects when the population was measured. And for W equals 1, 16,200 represents 1 week after. You can see how it tripled that way. So let's go on down here to the do you understand, and then we'll wrap it up here. All right, this error analysis is good for us. A student incorrectly simplified this expression x to the n over x to the negative n times b to the 0 as shown at the right. Find and correct the student's error. I'm going to ask you to hit pause and see if you can take a minute on your own and figure that out. Go ahead and hit pause now. Okay, it says, if you hopefully thought through it, it says, did the student work correctly with base x? So in other words, did this x to the n end up in the right place? Okay, well, it's a positive exponent. Remember the rule of simplifying, you have to have positive exponents. So that's upstairs, it's positive. We're going to keep it there. So yes, the x is correct. How about base a? A to the negative n, okay, it's a negative n, you have to move it because it's negative. So they moved it upstairs, they made it positive. Okay, I agree with that. So far, so good. How about base b? Base b, they said, is b to the power of 0, which they changed to 0. Is that correct? No, it's not. What error did they make? They said the error was b to the 0 equals 0, which is false. Okay, because we learned that anything to the power of 0 is 1 except for base 0. All right, to correctly simplify this expression, it should be a to the n x n over 1, or you could just, since it's over 1, you could just say a to the n x n. Okay, so being able to work with the basics of exponents is going to be kind of a big deal for us here coming up. So study these videos, and we will see you soon.